Hello, my friends of Catary Labs. My name is Saul Montoya. Please welcome to this tutorial of regional groundwater modeling with ModFlow and Tupac Cloud. So we have improved our online tool in order to do regional modeling. So first you sign with your email and your password, sign in. Okay, and then we are going to generate an that is called Modelo and Gas Cancha. Okay, and this is regional model. Regional model. Second meter, this is the APSG code, and then we are going to start from GR 2003. Okay, great. We edit that. We have the mesh limit. So you are going to receive this on the description of the video. This folder, you are going to receive this one. Okay, so we work with zipped chef files. So this is the model limit. Upload. We only have one refinement layer because even though that we have recharge and evapotranspiration, we always treat that as regional, and the only local or like non-regional is the drains. So that's why here we are going to have one refinement layers, and the drains will be the dissolve. I mean, is a of the channel network is a dissolve. I mean, it's only one multi-line. Okay, so and a zipped one. Okay, so we see save, and then we are the maximum cell size by default. This is adapted to the dimension of the shape file, and we start with 3 refinement stages. In the freemium version, you only have 3 refinement stages, so that's it. But the quality of the grid is pretty impressive. So that's it. Okay. And if you want to do or to have something more, like if you want to see how the mesh is made with the grid, the refinement layers, the interiors, the buffer. Okay, you can play around with that. That is how the Voronoi mesh has been created. Okay, then we do cell 2D and continue. On the vertical, we are going, the digital elevation model is here, the them, and we are going to work with 3 layers. So this is the safe. And then we are going to work with 2 stress periods. The first stress period is from the 1st of January to the 2nd of January. One time step is transient, and this is 02, 01, 2003, 00, and this is 222, 01, 2003, 0, 0, and 0. And this is, we can do now 1 multiplier and 4 time steps. And now this is steady and this is transient. Okay, this is so easy to define this. The solver is okay for us. Complex, you can use simple moderate. We are going to use complex. And the hydraulic conductivity will be 5 10 to the minus 6, 5 10 to the minus 7, and then here 1 10 to the minus 7, and this is convertible, and this is convertible as well. And then here the specific storage is 1 10 to the minus 6, and this is 0.05, the specific yield. The initial heads is the model name, so we assume that everything is, I mean, this is for the steady state. Okay, and then, well, we don't have wells, but we have drains from top. This will be from top. Okay, so this is our drainage network. This is depth from top, so it's a 0, so it will be that our drainage network is at model top, and the conductivity is 1 10 to the minus 3 for both. Great! And then we have the recharge file. We just give the model limit as the recharge file. Okay, so under digital conditions, the recharge is 100 millimeters per year. That is in meters per second. That's 310 to the minus 8. And then for the evapotranspiration file, we also give the model limit that it has, but this is 1000 millimeters. This is the potential evapotranspiration. This is 1000 millimeters per year, so this is 10 to the minus 8, and the routing depth is 1.5, 1.5 upload. Okay, great. So you have everything that, because you have already the solver, okay, the storage, the initial, the solver again. Yeah, well, I have to take this out. It has to be just one here. Okay, and then here we can run the model, generate and run. Okay, so this is going to generate and run. Okay, so this is the flow pi condition, and this is the the report, and it says that it has just taken it has one convergence. One time it didn't found convergence. So we go to the balance. So this is the balance. Mm, mhm. We see that there is few. I mean that this is in transient, and there are almost zero. But if we go to the volumes, there are some inflows. Yeah, from for example, there is a depletion on the, but those are minimal in comparison with the recharge rate, for example. Mhm. And then if we want to see the heads for a certain layer with the drains and the grid, so we just can see this, and then we can see that as a grid. Okay, for the second stress period, this is the transient one. Okay, and as a grid, and maybe you want to see that for the second stress. Mhm. And then there is no drain because no drains are installed in the first layer. Okay, then what we have, we can see the water table of the second stress period, and this is a geospatial representation of the water table. Okay, even that there is, because this come from Matplotlib, because this is actually outside the scope here. Well, sorry, this is auto-generated by Matplotlib. We are going to fix that, and then we can do some cross sections showing yes, and this is the cross section. Okay, so that's it. So this is how Tupac Cloud works on a regional model. Pretty it's pretty smooth. The way that it works is pretty easy, and it was intended to be clear and friendly. Uh, these are Flowpy generated graphics, so and I think that this is, I mean, why you see it twice is because it's kind of doing that is related to the DSB approach. Okay, um, but that's it. Okay, I hope that you enjoyed this tutorial. You can practice around, Then you can later tell me your commentaries to saulmontoya@hatarilabs.com and see you in another tutorial.